So this is day 3 of the advent of code, and in the first part of this problem, of today's problem, um, what we have, it's a lot of stuff there is to read through, but basically in the first part, you have been given a number of binary strings. Binary strings means they can only have ones or zeros, and considering only the first bit of each number, there are 5 bits and 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. So basically, for each position, if we consider this number, this is 0 0 1 0 0 and this is 0 1 2 3 4. So 5 characters, and for each position, we will go through the entire list of numbers which we have been given and try to find which number, either 0 or 1, whichever has the maximum frequency at that particular index. And if it's 1, then the element at gamma at that index would be 1. If it's 0, then the element at gamma at that index would be 0. Now, this should be pretty simple to implement using a dictionary or a hash map. They're the same thing. So, using a dictionary, just keep a count of the maximum element. Keep a track of the maximum element with the maximum frequency at a particular position, and framing gamma and epsilon from that. Actually, epsilon would be the complement of gamma. So if gamma is 1 0 1 1 0, then epsilon would be inverting, complement would be 1 0 1 1 0, complement of this is 0 1 0 0 1, and that is epsilon. So converting those two to decimal and multiplying it would give the answer to the first part. Now, the first part, if you thought that this was a lot to read through, the second part has even more to read through. But to just focus on the important parts, let's consider first the oxygen generator rating. For oxygen generator rating, what we have to do, determine the most common value in the current bit position and keep only numbers with that bit in that position. If 0 and 1 are equally common, they have asked to keep values with 1 in the position being considered. The examples are pretty self-explanatory. So in this number, say, so in this bunch of numbers, in the index 0, the element with the most frequency is 1. So we only keep the numbers which have 1 in the 0th index. So we keep this, we keep this, we keep this number, we keep this number, but we don't keep this or this because they have 0 in the starting index. And we keep this, we keep this, we keep this as well, but we don't keep the last two numbers. So filtering them out, we have these numbers left. Now, among these numbers, we will compare the, we will repeat the process for the next index, that is for the second index. So in the second index, this has 1, this has 0, this has 0, this has 0, this has 1, this has 0, and this has 1. So the frequency of zeros in the second index among the filtered numbers is more than the frequency of ones. So we keep the numbers which have frequency 0, and we remove the numbers which have 0 in the index 2, and we remove the numbers which have 1 in the index 2, which means we will remove this, we will remove this, and we will remove this. But we will keep this, 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 and this. And likewise, we keep repeating the process till we only have one element left, and that would be the oxygen generator rating. Similarly, for the CO2 scrubber rating, we will do the exactly same thing, except that instead of finding the element with maximum frequency at each index, we will find the element with the minimum frequency at each index. Now, if you think about it, in the first position, 1 has the most, in the 0th index actually, 1 has more frequency than 0. So to find the oxygen generator rating, we will take 1. But to find the CO2 generator rating, we will take 0. So we will take the opposite in both the cases. If you take a 1 in oxygen generator rating, then to generate the CO2 generator rating, it would be the exactly opposite digit, since a binary string can only have ones and zeros. So to simplify it, this is my function. I'll just split the screen. So this is my count function. Whatever I spoke about the operation, this function does it. What this does is, initially we consider the frequency to be 0 and the length. I'll come to what the length is. And okay, let me just go through this. So oxygen and CO2 are two dictionaries. We take two dictionaries, and at the very beginning we say that we don't know which number can be, like, among these numbers. When we are starting out, we don't know which one is the oxygen generator rating and which one is the CO2 generator rating. Anyone can be. So all of these are possible numbers. So we initialize we take these numbers as the keys, and we initialize them against 0, which means all of them are possible. Now whenever we find a number which is not possible, like for oxygen generator rating, if this number is not possible, we will simply change this to 0. Okay, which means that this number cannot be a possible oxygen generating, what's the word for it, this number cannot be a possible oxygen generator rating. So in the count function, what we're doing is, for key in dictionary, we are passing the oxygen dictionary here, and we say that for key in dictionary, for every number which is in the dictionary, because these numbers are the keys of the dictionary, of both the dictionaries. So if dictionary key, which means if dictionary key is equal to 1, which means if the number is still a possible oxygen generator rating, then we will increase the length to be 1. We are actually just keeping a count of the number of possible oxygen generator ratings. So now if this, which means that if the element at that particular index is 1, we will increase the frequency. Now please keep in mind that we are only keeping a track of the number of ones. We are not keeping a track of the number of zeros. We are only keeping a track of the number of ones at that particular index. Now, if length is equal to 1, which means that there is only one possible number left in the dictionary, and obviously that will be the number which will be the oxygen generator rating, because there simply are no other numbers against which we can check. So that will be the oxygen generator rating. So if digit equal to 1, if frequency. So if frequency greater than that, which means that if the number of ones is more, then digit is equal to 1. Otherwise it's 0. And if check, now we pass the check because we want to find for both oxygen, we want to find both oxygen generator rating and CO2 generator rating. So we pass the check variable to just like keep a track of which we are trying to find. If check is equal to max, because remember that for every iteration in oxygen, I mean, whichever in a particular index, whichever number has the more frequency, if one has more frequency, then that will go into the, we will keep a track of it for the oxygen generator rating, and for the minimum numbers we will keep a track of it for the CO2 generator rating. So this is what this thing basically does. It just flips it and sends the value. And eliminate. Now eliminate function, what this does is, For key in dictionary.keys, if it's a possible value and this is not equal to digit, that is, digit is the number with the most frequency at that particular position. And if the certain key does not have it, for example, in position 1, digit is 1, and this number does not have 1 at index 0. So we will remove it from, like, we will say that this is not a possible answer for this. So this is what eliminate does. And then there is the multiply function to simply find out which key is the remaining one, and that we convert that to integer and we multiply them to get the power. Oh, sorry. Yeah, this was my answer.